For our submission, Identifying Hotspots, Analyzing the Impact on Vulnerable Populations Using GIS, we worked in partnership with the City of Melbourne's Climate Change Adaptation Team.
Extreme heat is Australia's most deadly natural hazard, as it causes more fatalities than all other natural hazards combined. As you can see from this graph on the left, temperatures have increased more than 1.5 degrees Celsius over the past 100 years. The impacts are exacerbated by the increased temperatures in urban areas. These can range anywhere between 1 and 13 degrees Celsius, as you can see by the graph on the right. More specifically, we focused on vulnerable populations within those urban areas, which in Melbourne are those that are older or in lower socioeconomic demographics, as they are disproportionately affected by heat.
The United Nations has 17 Sustainable Development Goals established to achieve an equitable and more livable future for everyone by 2030. While the problem of extreme heat is addressed most directly by the Climate Action Goal 13, our project also aimed to improve the good health and well-being of residents. Our focus on vulnerable populations aimed to eliminate some of the heat-related discrepancies experienced by these communities, and our findings and strategies for Melbourne could be implemented to create more sustainable cities and communities around the world, supporting goals 3, 10, and 11. By understanding the issue behind our project, we hope to empower the City of Melbourne to mitigate the impact of urban heat islands on vulnerable populations.
In order to do this, we developed the heat score, which is a weighted equation we created to analyze the intensity of different hotspots to prioritize areas of intervention for the City of Melbourne. This is our subjective weighting scale that we use for our heat maps. Now, this is the block scale map that we were able to create using our heat score. The color scale shows us the clear differences between the more vulnerable locations in red and then the less vulnerable locations in green. The most vulnerable areas are very prevalent near the northern part of the central business district and into some of its surrounding areas. This part in particular contains Chinatown and the Queen Victoria Market, which we determined were noticeably hotter by analyzing them firsthand. This analysis provides a more streamlined approach for the City of Melbourne to mitigate hotspots, and the dynamic weighting scale allows the city to manipulate the heat score equation to target particular metrics. All of our GIS map analysis can be brought together in our web application, HeatSmart AI.
HeatSmart AI, pictured on the left, is a tool we've created to synthesize our GIS map layers, our dynamic visual library, and modern artificial intelligence. It perfectly complements the City of Melbourne's current software, Compass, which is shown on the right. By fusing these technologies, we're making strides towards revolutionizing geographic information system software and the urban planning industry, resulting in improvements in human thermal comfort. This is the base map of Melbourne with no GIS layers enabled, but when we check one of the boxes, we can see the layer appear on the map. And due to our selective custom color scaling, when another layer is checked, for example parks, we can clearly see both layers together. And this process applies for any number of layers. You may have also noticed the checkbox in the bottom left that says Show Markers. When that's selected, pinpoints show up across the map, which are the locations for our visual library photographs. When a user clicks on any one of them, they'll be able to pan around this 360-degree image to obtain a street view of Melbourne. And perhaps the feature that makes HeatSmart such a unique software is the AI chatbot. Users are able to write in the chat box whatever they want to take away from the GIS map or what they want to include in the GIS map. The AI model will automatically select only the relevant layers and enable them, minimizing clutter while maximizing the conclusions that can be drawn. For example, I've asked to see the population heat score as it compares to greenery in Melbourne, and the software enabled the population heat score layer and the parks layer since parks often contain dense greenery. In the future, the city can use our robust multi-method approach to apply to similar projects, utilize our technical tools to increase analysis productivity, and combine the user interface and database connection of Compass with the technical features of HeatSmart AI to enhance their current software tools. With these advancements, we anticipate looking forward to a smarter, more resilient city that is well equipped to meet the demands of the future. Thank you for your time and consideration.